Welcome to another Genie webinar. My name is Ben Newton. I'm a graduate student at the University of North Carolina at Chapel Hill. And we have funding to support some efforts here. And one of those efforts is to host this series of webinars. And it's a great opportunity for people who either are new to Genie or who do research with Genie already to get a feel for what types of research are being done there, what are some of the tools and tips and tricks from the leading experts that do things with Genie. So today it's my pleasure to be able to introduce to you Nick Baston. He is someone who has a large range of experience with networking. He's worked at several companies, including OpNet. He's done some OpenFlow research and development at Stanford, and he's been he was a technical staff member at Big Switch Networks, and he's currently a research assistant professor at the University of Houston. And one of the many things that he's done for Genie is this GENI-Lib. And it's our pleasure to hear from him about GENI-Lib and how to get started with GENI-Lib. We'll turn the time over to Nick Baston.
Thank you, Ben. I'm just going to do a short presentation, and then just to give a rundown on what we're going to do here. A short presentation, and then we'll do a couple of demos. My hope is that people will have questions, and we can sort of drive it the way people might want to. Otherwise, it might be, you might get some of your hour back. So let's get started. So GENI-Lib, if you haven't heard of it before, is a Python library for working with Genie resources. And anything that talks to Genie AM API, the Genie clearinghouse API, the RSpec XML formats, the results of these APIs, that sort of thing. So it can it can both produce RSpec, parse RSpecs, deal with all of these POA returns, these sorts of things, and can also communicate with Federation components directly. So you can use it for a wide range of things. But basically, it's Genie scripting in Python. Instead of using, say, JAX or the portal or Genie desktop or something like that, this is a way that you can write script. So that goes to, of course, what it's for, which is sometimes we want to be able to easily repeat our experiments or easily scale them up and scale them down. Maybe you want to try one site to make sure your experiment works, but then you want to run it to 20 sites to get a bunch of good data. GENI-Lib is perfect for this. You can build this out and then just scale it up to a bunch of different sites easily. You can also use it to build tools. For example, part of the Cloud Lab portal is built using GENI-Lib. It uses it to build RSpecs to generate based on the profiles that you've asked for. So you can do very simple tools like the experiment graphs, if anyone remembers from the Genie wiki a long time ago. They're not up anymore, but it was a monitoring tool that went around and asked all the aggregates, how many raw PCs do you have available, how many VMs do you have available, that sort of thing. That was built using GENI-Lib. So you can build very simple tools. You can build super complicated tools. You can build almost anything you can imagine. You could build something like the entire portal or JAX itself using GENI-Lib if you wanted. If you're going to build tools or you're going to use GENI-Lib deeply, you probably need to understand a few pieces of the Genie Federation architecture if you don't already, although I recommend that everyone understand these things regardless of the tool that you're using. So there's a link here which will put the PDF up on the wiki, and you can go through this if you want. There's a link here for the Genie software architecture document, but I also have a picture here. And this is important. When you interact with the Genie Federation with a low-level library like GENI-Lib, you need to know who you're talking to. When you go to a tool like JAX or the portal, it knows to talk to the clearinghouse for some things, aggregates for some things, the slice authority for other things. You need to know these things when you are writing stuff in GENI-Lib. It's relatively straightforward. It tries to solve a lot of these problems for you, but it's good to remember that I get my credentials from one person, I make slices at a different place, and then I get resources at a third place. So just keep this federation interaction in mind, sort of key to all of how Genie works. Having now scared everyone away with building tools and writing scripts and going crazy with Python, one of the most popular uses of GENI-Lib is actually its interactive use. Because it's written in Python, we've created some thin tools around Python and GENI-Lib that allow you to work interactively at a terminal. And I'll show you two examples of this, and then you can also use it in iPython or Jupyter, if you are familiar with that, for other domain science stuff. And we have a really nice environment that I will do a bunch of demos in that can be used that way. And then, of course, as you go through your interactive use, you can just save those snippets, write them into files, and then run them as actual scripts later if you want. So it's a really nice workflow. To hit some high-level features, GENI-Lib tries to do everything Genie covers. At the moment, we have a bunch of support. Most EmuLab, InstaGenie Cloud Lab extensions. We can handle stitching. We have all the VTS extensions. It works with AM API v2 and v3. There are some pieces of ExoGenie that haven't been implemented, but in general, you can get, ExoGenie resources, VMs, and that sort of thing. So if we're missing a feature that you need, let us know. Which sort of comes to here. If you start using GENI-Lib and it doesn't do something you needed to do, or you don't know how to get it to do what you needed to do, you can file tickets. The source code is open. There's an issue tracker. We monitor it. And then you can also get usage help from the Genie users Google group. And there's a bunch of documentation which has been linked somewhere in here. Right down here at the bottom, there's a bunch of documentation online, and it's also on the wiki page for this webinar. So I'm going to go to the demos unless anyone has any immediate questions. All right, sounds like we're good. So the easiest way to get GENI-Lib installed on your computer, and the whole point here is to sort of get you up and running, get you started, is to use the Vagrant Vm. If you've heard of Vagrant, it's basically a infrastructure for creating VirtualBox VMs where we provide you a file that tells the VM how to instrument itself, and then it builds itself up. So I'm going to go through the motions here right now, so you can see how easy it is. So basically, what we need to do is go to the portal. Okay. So I need to download, like you would for using Omni. And these instructions tell you this. I'm just sort of skipping ahead. But you need to download your Omni bundle. Okay, so I did that. Now what we do is we download the Vagrant file. You have to have Vagrant installed, obviously I do. So I've downloaded this Vagrant file. I'm going to copy from my downloads my Omni bundle. And this is all I have. I downloaded the Vagrant file into here with the instructions from the web browser. I copied my Omni bundle into here, and then I just told Vagrant to run it. So what's happening here is it's downloading a base virtual machine. It's running the Vagrant file, which is downloading GENI-Lib, provisioning it, and then it automatically opens up your Omni bundle and configures your VM for you. So that's all you have to do. This will take a few minutes. If you have a faster internet connection than me, it will take less time. If you have a slower internet connection than me, it'll take more time. While that's doing that, I can show you a quick little example of the Genie shell command line interface. So one of the advantages of interactive use over Omni, for example, is simply that you only have to type your passphrase once. A lot of people have stripped their passphrases from their private keys, but this is a really bad idea. So as long as Genie shell is running, the passphrase is good. So for example, I'll just run through, we'll do a much more in-depth thing once the Vagrant VM is up and running. But I can do some, basically this is a Python interpreter, so you can do, normal Python stuff. but we've also installed a bunch of GENI-Lib stuff. So you can see the CLAM, EGAM, those are aggregate managers, and there's documentation for all of this. But we can do very interesting things like I know I have a slice at NPS, a sliver at NPS, and I can ask for its manifest. And there we have a manifest. And then I can do stuff like print the login info of this. Oops. Easy stuff. Just skims over your manifest, grabs your login info. Maybe I want to know when it expires. Perfectly in there. And this is especially useful when you want to write scripts, obviously, because you need this information programmatically. Now, what has happened is we've made a VM that exposes on your local host at port 8900 a Jupyter web interface. Jupyter is the new name for iPython. It's a little more complicated, but it's all set up for you. There's a getting started notebook already in here for you, so you don't need to remember how this works. I won't go over it now, but it basically tells you how to load GENI-Lib in your notebooks, talks about the pre-imported shortcuts, and then some special features that it has, and then how to update it. We will ignore that for now, because I'm going to tell you about it. So you can make a new notebook like you would with any iPython environment, and then what you do is you load this Genie-SH extension. It always asks you for a password. If you don't have one, just hit enter. So what we're going to do, for example, now is, let's say I want to make a slice. So I'm a member of a project, but maybe I'm a member of a lot of projects. So let's find out. And of course, in Jupyter, you can tab complete. So it turns out I'm a member of two projects, this 4421 Spring 17 and 4421 test. So let's be nice citizens and not screw up our undergraduate class. And I will set my project to be the test. And now I want to make well, actually, we could do something crazy here. For example, we could ask the clearinghouse about all the projects. For example, if you're looking for a project. Now you can see every project in the clearinghouse. And one feature of the iPython interface that's nice that we've added back here, stick this in a list, and then we can do something crazy like because this is just Python. Then it prints it in columns, but that's pretty annoying. It's too wide. So because it's just Python, and this is sort of the useful sort of quick demo of, look, it's just Python. We can take just the names, for example. But, they're not in order. So let's widen it and sort them. So all that stuff very quickly, you've now just browsed all of the projects, over and over again on the clearinghouse, stripped off the data you didn't need, sorted them, and viewed them. So like this stuff is pretty easy to do to get the information the way you want it in Genie-Lib. And then of course, because it's iPython, you can just compress these things back down again. But we need to make a slice. So we don't know how to do that. I mean, we sort of know how to do it, let's say, but we don't know what the arguments are. So create slice takes our context. If you read through the documentation, the context is the thing that knows everything about your user URN, your credentials, that sort of thing. It tries to handle most of the magic for you. But so you end up passing it into lots of methods. So it's just important to remember that your context is important. And if you want to change your project, you do it there. If you want to change your user, you do it there, that sort of thing. But we can make ourselves a slice. Now it takes an expiration. So it's Python, so I should probably get myself a way to make an expiration date. Let's make a slice called webinar, and let's set its expiration to now plus, 6 hours. And the clearinghouse just made me a slice. So this is the same thing that would have happened if you'd gone to the portal, gone to your project, clicked on the link that says make a slice, and then typed all this stuff in. So you've done it automatically. This is super nice if you want to make short-lived slices per experiment, for example. You can just conjure them up, use them, and then they'll throw them away. So now I have a slice called webinar, and I want to make, let's say I want to do some networking research. So we want to get ourselves an OpenFlow controller VM from Genie. So let's make a request. Now, it doesn't matter that we're doing pg.request. It's just all Genie requests are sort of PG. That's the history. But we want a Zen VM. Of course, these things tab complete. We'll call it VM0. And we want some very basic stuff. We want its RAM to be 768 megs, and we want to get a routable control IP. I forget how we spell. And bam, we just made ourselves an RSpec, a request RSpec. So if we were to look at it, maybe we should make it pretty. Now, this is a simple example, of course, but you could see how you could build a bunch of control structures and easily whip yourself up a giant topology without having to write all of this XML. So now that we have this, I want to ask a site, let's say NPS, because we think it works, on our webinar slice to make this sliver. Oh, and we would like to get the manifest. And this, if you've used iPython before, when there's a star here, it's that this is working. So it goes out to NPS. It asks it to do this. I mean, it's the same thing if you were, running in Omni, you would see a bunch of stuff spewing by. And in fact, actually, we can do that too. Just you can enable a bunch of logging if you want to see that kind of stuff. So we have a manifest. And in fact, if we just view it, we can see that it expires today, soon. It has one node, no links, and it's at some location, which I presume is NPS if someone filled that out right. Now, this sliver invariably isn't ready yet, but I kind of want to know what the IP address is that it gave me. Now, I can look at the text just like I could with Omni, but again, this starts to get annoying. It's not very useful if you want to script it. So what we want to do is something like this. So we only have one node called VM0, and its IP address is this. We'd like to store that in a variable. So let's go back here. We only have one, so we'll do this horrible thing. Obviously, that wouldn't work if you had lots, but in our case, it works fine. So while NPS is busy chugging doing that, we can now ask it, for example, about our login info for this VM we just created, and it tells us, here's our username, here's the port. We ask for a routable control IP, so we get port 22. If you don't, you get port, 30,300 and something, and this is the host. So this is the kind of useful information that you can get. There are, you can easily build, wrapper scripts around this, for example, to auto-generate SSH config files and that sort of thing, which is super handy. So now that we want to, we'll actually do a quick little VTS demo in here too because it's a little bit faster. We have this thing that we're going to use ostensibly as our OpenFlow controller. It's going to be at this IP. So now what we want is to build ourselves a network topology. We should. So let's say we want a router and 3 LANs, and each LAN has 2 hosts and a DHCP server, and they're all connected through the router. So we ask VTS for a container, Quagga image, and then this is where the power of GENI-Lib really comes in. We can make loops. So let's say we want 2 lands to be OpenFlow and 1 land to be L2. I don't know. We're just making stuff up here. So every other land. So we'll make a switch for each land. We have to name them uniquely. These are client IDs. So like any Genie request, the client IDs have to be unique. The other ones will make OpenFlow images. And we have our host IP. Now we have 2 lands, and we want to have 2 hosts for each land. And the key point here is not really to understand exactly what I'm doing. It's sort of to get the idea of the power of this, and you can look at the documentation and get us to help you with various things later if you like. We can, of course, because we're in the browser, we can copy and paste, which will save us some time. So we're naming our client IDs. These will turn out to be host names later. And then we'll make a DHCP server for each one. And we'll give them a subnet, and we need to do something to make the subnet variable. So we'll put the number in there that we've been using for the LAN. And then we'll name it something, LAN number. And now we need to make edges to connect these things to each other. So we're going to connect router 0 to the data path. We're going to connect the data path to H0, data path to H1, and the data path to DHCP. And then we broke something. Conveniently, it tells us all about it. Oh. Except I just tried to add all of these to our Genie request. It was not going to go well. Okay, we missed one. Okay, so presumably we have a functioning request now. So let's ask the, BTS site at Illinois to make us this split. Same slice name. No, we want to capture the manifest. And while it's doing that, we're hoping that the Genie VM is imaging and booting and coming up. I mean, we're obviously not really going to run an OpenFlow controller on it, but it'd be nice if it came up eventually. But I mean, obviously, I am very familiar with GENI-Lib, but we've made a fairly substantial set of requests here without dealing with painful XML and those sorts of things, and we've scripted it out pretty well just in this interactive interface. So if we do, we got a bunch of lands here. So let's see, land 2, well, actually land 1 was the one where we had L2 because we don't know OpenFlow controller up and running. So now we will go log into one of these and see if we can, get an IP address from the DHCP server. The interesting part here is that now we can go over and get a terminal from Jupyter as well. So just right here in our browser, we can get a terminal. Now, what your SSH info is sort of depends on what you told the portal. If you're a default user, you had the portal generate your keys for you, you clicked all the default buttons, then it looks like this. And you can just SSH and tell it, ID Genie RSA. If you supplied an SSH key to the portal, these names will be whatever name you gave your key. So I can't tell you what your SSH key is going to be called, but it's going to be in your SSH directory. You can just go look at it. So now we need to go to, well, where? UIUC.bts. Copy that. Perfect. Now we're logged on to our host. We can now go back and say, for example, look at sliver status for our Genie VM. See if it's ready. This is a little bit raw. You can always get raw results, but these are the types of things that you can inspect inside your code. You can see that your Genie status is ready. If it wasn't, it would tell you failed or not ready, and then there would probably be more information in here about what had happened. You can, of course, save these notebooks. You can send them around. You can make them for your classes. You can make reference notebooks. If you look at the Getting Started notebook, you can put markdown in these cells. You can open and close them. You can make some real nice presentation. We find this especially good for classroom work, that sort of thing. So, I mean, this is the gist of the interactive interface. If anybody has any questions about this iPython part or the scripting part or really anything at this point, let me know.
Nick, I have a question. How did the information get here as far as your project and whatnot? Did that have to do with the Omni bundle, or was that when you did the initial commands outside of Jupyter?
It's your Omni bundle. So when you download your Omni bundle, it asks you what your default project is. Now, as it turns out, we downloaded an Omni bundle whose default project was this,
right?
But then we changed it.
Sure.
And you can ask it what your project is. In fact, if I run it now, it'll be different. But you can also just assign it, and then it changes your project. So if you have multiple projects or if you have multiple slice names, you can just change the name you're currently working on, and everything changes its content.
So if you get added to a new project, you have to re-download your Omni bundle. Is that correct?
No. So I downloaded this Omni bundle, and it only has one project in it. If you were to look at the Omni bundle, it only has information about one project in it.
Okay.
This line here asked the clearinghouse, what projects am I a member of?
Right.
And it told me I'm only a member of 2. Right. If I were on my actual account, this would show me like 10 projects. Or if you've been to a GEC, you're probably a member of a GEC project that's still hanging around, or stuff like GEC tutorials, that sort of thing. So it would tell you that. Then you can just change your project by copying this text and setting it. For classroom situations, that sort of thing, most people tend to only be a member of one project. So the Omni bundle setting your default project tends to work out okay, and you don't have to deal with that. But it's trivial to change your project. You should never, this is important, once you've installed your Vagrant VM, you never need to download your Omni bundle again until your credentials expire. So like once a year, you have to go back to the portal, get a new SSL certificate, and it's often easiest to just download a new Omni bundle. You can actually replace the SSL certificate, but you have to know where that lives.
Sure. Thank you. This is also a question that I'm not that familiar with Vagrant and whatnot, but let me just make sure if I understand what's going on. So Vagrant is actually a virtual machine that's now running on your PC, and
right.
It's creating a Jupyter server there that you're running this through, and then from Jupyter you can get to that terminal. Is that kind of the way to think of it?
Right. So when you connect to your Vagrant, so going back a little bit to the start, if you go to the GENI-Lib docs, there's installation instructions for a couple of Ubuntu's, Mac OS X. There's no more Windows instructions anymore. They've shipped so much, it's hard to keep it up to date. And then there's these Vagrant instructions. They walk you through this. So like getting VirtualBox, for example, and getting Vagrant. So that walks you through the sort of infrastructure that you need to build a VM on your machine if you don't have those pieces already. And then once you've done all that, down here, load the Jupyter web interface. So open a new web browser and load this localhost at port 8900. That shows you this.
Right.
And then you're there. And then when you want to make a new notebook, you can come down here to new and say Python 2, or you can say new terminal. Terminal is, the term. You can also SSH into this Vagrant VM, you know, if you want to use your own terminal. This thing's a little bit limiting. You can't really, it's small in this presentation, but it's also just small. If you widen your browser window, it doesn't get any wider. I mean, there's all kinds of sort of problems with this, but for a classroom environment, it's pretty nice to not have to tell people how to use PuTTY or how to use, you know, various things.
Sure, yeah. But this is a terminal that's running inside of Jupyter, inside of the virtual machine.
Right.
And it's virtual, it's a VirtualBox virtual machine, and Vagrant is the tool that essentially enables an easy way to kind of create a virtual machine instance in a VirtualBox virtual machine.
Right, so if you, I mean, in fact, we can look at this. The Vagrant file is the thing that you downloaded that made this virtual machine. It's maintained by us, and it just tells it how to install GENI-Lib and all the dependencies, and you know, move and automatically configure based on your Omni bundle and those sorts of things. So we skip all these steps that you would have to do otherwise manually.
Perfect. That's great. Thank you.
Copies in the Getting Started notebook and a few things like that. So it tries to make things easy for you, and we keep this up to date. And it's pretty easy to just throw it away if you're not using it anymore, and then start using it again. It's no problem. You can start and stop it. You can destroy it. This Vagrant directory right here is shared with your host. So if you copy, your notebooks are in your home directory. So if you copied these into your Vagrant directory and then destroyed this VM, they'd be on your host file system. So like you can back them up, that sort of thing. So it's pretty lightweight, it's pretty convenient.
Thank you.
Hey, Nick, you mentioned classroom use of GENI-Lib, and so what kinds of things do you do in a classroom with GENI-Lib that, I mean, there are a lot of instructors using Genie, and they typically use the standard tools such as the portal and JAX. What kinds of things do you do with GENI-Lib?
I mean, unfortunately, I don't have, well, actually, I can show you something cool. The terminal, there we go. Our entire undergraduate networking class is taught using iPython and GENI-Lib. We only ever use the portal to make accounts for people. So we actually have a Jupyter Hub server. So hold on, I gotta figure out what the heck my password is. So all of our students log into this shared Jupyter server that we have. And I'm an admin, so I can show you, for example, that like these are all student servers. So if you're a teacher or an instructor, you can actually access these servers, look at their notebooks. They can turn in homework through their notebooks, that sort of thing. So you can sort of easily manage a whole class. And then you only have one version of GENI-Lib installed. You know that everyone has the same version of GENI-Lib installed. We used to do this with VMware VMs, but then people would have, you know, random problems with their setup, or they'd break it or something. This is a centrally managed system that we use. So now everyone has exactly the same setup. So let me see, well, let me steal Denise's server. We should have, you know, lab demo notebooks. So all of the work that we do in this, for example, you can see like MAC addresses dumped from a bridge and stuff like that. All the work that we do in the classroom, all the labs we do in the classroom built around our intro to networking class are done this way. So we have a whole, 16 weeks of coursework for our intro to networking course that's built around using Genie and then using this iPython setup.
Nick, and so you said that It works for Windows. You just had to remove the instructions because they have changed the setup. Is that right?
It works on Windows. The problem is it's sort of Windows is a moving target. I mean, Mac OS X is actually a moving target as well, so it's a little bit of a problem. But you can install this natively on Windows. It requires Python and a few other things. It's relatively easy to install, but you kind of need to know what you need to be a Windows user and know what you're doing. And we're not really Windows users. So I've tested it a few times. It works great, and then like Windows patch something will come out and make SSL work differently or whatever. And there are fixes to all these things, but I have to figure them out, which is why we ended up going to the Vagrant VM for most users.
Got it. Perfect. Thanks.
If someone really wants it to work on Windows, we can sort of revisit our documentation for Windows. But that's what I was sort of saying at the beginning during the presentation, which is if GENI-Lib doesn't do something you need, if you need it to, have some RSpec support for some obscure feature of like something that you know about that we don't know about, because this happens, Utah adds features for people, that sort of thing. Just let us know. If you're using Windows a lot and it's a problem that people have to use Vagrant or something, just let us know and we'll revisit it. This is driven by the users. So for the most part, what's documented, what works, what features there are, they're entirely driven by what users want to actually use. There's some basic how-tos in this documentation. Like about creating VMs like we did, extra Genie, exo small, InstaGenie, Zen VM, that sort of thing. There's some documentation, and these are for writing scripts, so they require some sort of importing versus using the interactive tools. If you're using the interactive tools, you can skip some of these things. But you can jump through, advertisements, parsing advertisements, figuring out what's available. We actually use this to really good effect in our experiments by parsing advertisements before we make reservations in order to find the sites where reservations are most likely to succeed. Instead of waiting for, because it turns out in the advertisement, it tells you, how much RAM and how many slots are still available. And so if there isn't enough RAM or there aren't enough disk available, we won't use this site. And you can script that all out so you don't have the problem of waiting and then being like, oh, it failed. Great.
In your class, when you do things with the students, do you do graphs, and do you do that through Jupyter, through iPython, and how does that work?
We do not do a lot of plotting, although some of our graduate students use Jupyter, and they do much more advanced stuff with NumPy and pandas and stuff like that, and they present a lot of charts and stuff inside of the iPython interface. But for our class, it's mostly tables. Like if we look over here, well, it's the topology, which is nice, and especially for classroom topologies, the topology viewer basically always works. If your topology is complicated, if you've used GraphViz, you understand it turns into a mess. But when it's small, it actually works pretty well. And then most of this is table driven, like what max has my data path learned, that sort of thing. What leases has my DHCP server given out. Almost everything. I mean, this is the intro to the networking course. We're teaching people about like Mac learning and ARP and stuff like that. So they're looking at tables of data more than charts.
Thank you.
Yep.
So next, if I understand this correctly, GENI-Lib is essentially for makes AM API calls or calls to the clearinghouse. Can I also use it to run commands inside the VMs I reserve? Something like Ansible might do for me?
No, right. So
okay.
Like we don't try to overlap with tools that already exist, like Chef, Puppet, Ansible, Fabric. In fact, in our class, we use Fabric to script executing things on the host in your experiment. GENI-Lib tries to make a clear delineation between, like, there's no point in us re-implementing, Ansible or something, right? That's crazy. So we try to make a clear delineation between where we stop and where other tools start. So if there's a tool available that, scripts connectivity to random VM that's been allocated for you, i.e. Ansible, Fabric, something like that, then we don't do that. But we allow the scripting of all the parts that you don't have scripts for, like all the Genie parts.
Mm-hmm. Yep, makes sense.
And there's a little bit of overlap if you've used the services of like Instagenie and Exagenie to install software through the request. GENI-Lib can do that, but that's usually the place where, like, for example, you hook that to install Ansible or Chef or something, and then you go from there.
Can I create stitch topology?
Go ahead, Vic.
Oh, can I create stitch topologies?
Yes.
Okay, so I would need to not only make the calls on the endpoint aggregates, but also on AL2S?
Right. You have to contact the aggregates, but the stitching RSpec extensions are in, like, there are library calls to build them. So you can, for example, build a multi-hop stitch path and then take that RSpec, give it to, one site, AL2S, another site. In fact, let me see if I can find a spot down here. There's a transit AM hook here, and there's Ion Max AL2S in Utah. And so, like, this is the Utah Transit AM that you might need to talk to, the one that sits between Cloud Lab, Apt, EmuLab, and Instagenie. And then I don't know if Max and Ion, if anyone's still running those AMs, and then AL2S. So if you want to stitch path from, say, DDC to GPO, you would stitch through DDC, the Utah Transit AM, AL2S Transit AM, and GPO.
Okay.
But you have the capability here to build all of the requests. You can parse these advertisements programmatically to find the path that you want, and then, build up your multi-hop path.
Yeah. Right. So you don't talk to the stitching computation service. I have to come up with my own path between the endpoints.
Right. So this could be a thing that we could do, but it does not currently have the ability to talk to SCS. But that's probably simple. I don't actually know. Like, that API, I suppose it's published somewhere. It hasn't gotten a lot of publication, so I don't know. But assuming that, Aaron or Tom or D or someone could tell me about this API, then what you would do is create the stitching piece at both endpoints, send it to SCS, get a full path back, and then do it.
Yeah.
But in reality, I mean, to be fair, because the graph is not that complicated, it could have been, right? But it turns out right now the graph is not that complicated. They're mostly all of the AMs are mostly connected to either AL2S directly or through one extra hop. You can just parse all these advertisements, build out your graph, and then just apply it yourself. I mean, it's only a couple lines of code to get your path that you want.
Sure.
But that's sort of the breadth of what you can do with GENI-Lib. You can sit here and do interactive stuff and never ever write a script, and it's still pretty handy. Or you can write deep scripts to inspect advertisements, to build a graph, to do effectively what SCS does or something like that. Or you can write a whole new set of tools. Or like what we do and our grad students do is build scripts that orchestrate their entire experiments. So when they want to run them over and over and over again, they just click a button and go off to lunch instead of doing it manually every time.
Yep.
It also sort of helps the repeatability situation where, like, I want to give this experiment to someone else so they can run it. Well, here's the script that did it, so there's no mystery as to what I did that I didn't tell you about.
Thank you so much,
Any
Nick.
other questions?
Are there other questions for Nick? Nick, is there anything else you wanted to cover, or is that pretty much it?
No, I mean, that's about it. I would say that if you are an educator and are interested in setting up your own, like, Jupyter Hub for classroom work, we can sort of give you some guidance on that. It's not totally simple, but we can sort of help out with that, and that's a really nice sort of classroom environment to work in. But if you're a student or an experimenter, the Vagrant VM is a fantastic way to work.
Great. So, well, thank you so much, Nick, for presenting to us. And hopefully everybody has a better feel for how to use GENI-Lib and what it does and it's the power of it, especially to script all of those interactions, especially, like you said, to be used for experiments you want to repeat or be able to show other people how they were done. That it sounds like it's a very powerful interface, and I'm hoping I can look into it a little bit more myself. So thank you.